Arthur and I both live and work in London. And I work for Trilitech, which is a company developing the Tezos blockchain and helping with its adoption as well. And Arthur, I'll let you introduce yourself.
Hi, my name is Arthur Breitman. I'm a co-founder of the Tezos protocol, and I'm a director at Trilitech, which is one of the companies building the ecosystem, be it the core blockchain itself, or helping companies adopt the technology.
And the blockchain has been live for quite a long time now. It's one of the original blockchains that were created in the very first wave of smart contract blockchains. And it's evolving quite a bit at this point. So we're here to present the latest developments in its journey to becoming a mainstream instrument for financial institutions. So maybe I'll start with the first question for Arthur. So many people here might know, or might not actually, how Tezos was created and how you came up with several others with the idea. Would you mind telling us more about it?
Sure. So Tezos was conceived in 2014, and it was conceived around three important pillars. One was governance, the idea being that blockchains were evolving, the research was improving, but there was no way to preserve the decentralization of blockchains while at the same time allowing them to upgrade themselves. And that is something that Tezos introduced with a formal on-chain governance where the different actors of the blockchain can participate and vote on making it better. And that has already happened 14 times since the launch of Tezos in 2018. And the other aspects were on proof of stake, ensuring a form of consensus that was not consuming large amounts of energy at a very high cost. And finally, smart contract language security, seeing that smart contracts were going to become important. We're going to secure large sums of money, but would be subject to dangerous bugs. So that's been the beginning of the journey. And I would say nowadays, Tezos, that was known mostly for governance and proof of stake, is starting to be known for its scaling abilities.
Yep, and scaling on Tezos is getting a shot in the arm with some of the latest developments we'll be working on, and that's going to come up in our chat a bit later. For the audience, can you explain what are the different blockchain layers, and more particularly, what is layer 2 and why it matters at this point?
Right, so obviously, unless you have several layers, you don't even talk about layers, right? But so what has been dubbed now layer 1 is essentially traditional blockchains. They have a set of validators that's dispersed, decentralized. They collect transactions, they put them into blocks, and they go on and they create consensus around those blocks. So that's the traditional model. If you look at this model, you can unbundle a lot of activities that those validators are doing. Instead of having them execute every transaction in particular, you can outsource that to a different system. And because the system is designed differently for a different task, it can be optimized for that task. So there's a bit of a division of labor that's happening between different technologies, which are better suited for different parts of the stack. So layer 2 is one way to scale. Blockchains in the past, as soon as people start using them, the blocks become full and the fees become very expensive, and now the chain is unusable. So with layer 2, by separating the computation of the transaction and the mere collection and ordering of the transaction, you unlock a lot more throughput. And on Tezos, we've been able to demonstrate 1 million transactions per second of throughput using precisely like the layer 2 solutions that have been built on and for Tezos.
Yeah, one thing that you guys might have noticed is when we turn our head, the mic works a little less well, but hopefully that's going to be good enough. One thing that I can add to this is that the flexibility that a layer 2 framework gives you in designing those use cases for you guys to be able to use the chains easily and in a way that makes sense for your use case is very welcome in a world that has been like, a one-size-fits-all type of mentality until now, with a set of trade-offs being chosen by each of the blockchains. So now one blockchain can actually satisfy several trade-offs and several use cases by having them directed to various layer 2s that might be designed for them. And so there is a lot of talk around that L2 scalability aspect. Why is it better to scale vertically as opposed to horizontally?
Yeah, so there's basically two broad approaches for scaling that have been proposed for blockchains, the vertical approach and the horizontal approach. The very idea of a vertical approach is that you say, I'm going to use a more powerful computer. I'm going to throw hardware as this problem. So very powerful computer, high-speed connections. That's the vertical approach. The horizontal approach is going to say, I'm going to do things in parallel. Rather than having a more powerful computer, I'll have just more computers. And it's often been thought that the right approach for blockchains was the horizontal approach. The reason being that if you have the vertical approach, you create centralization. All of a sudden now, all your validators have to have this very expensive stack of hardware. So there was a trade-off between the convenience of vertical scaling, where it's just one machine, it's a simple system, versus horizontal scaling, which in practice is supposed to have better properties, but is harder to deal with. And the paradox that many people don't see is that even though layer 2 solutions were invented at first for horizontal scaling, they're actually a great choice for vertical scaling. And this is because in a layer 2 solution, you've outsourced the computation. And as long as the computation is outsourced, you can use different hardware, you can use different providers for doing this computation without centralizing your layer 1. So again, this is a division of labor, which shows that all of a sudden the technology that you can use and the requirements that you can have can be adjusted.
And that last point is actually interesting. It's something that I didn't fully appreciate myself before joining Tezos and having discussions with Arthur over the last few months. I've been into the Ethereum ecosystem for a long time as well, and you have Arbitrum 1 and others doing things. But I didn't fully appreciate how even having just one layer 2 and one layer 1 for an ecosystem is actually in a lot of ways advantageous compared to just having a layer 1. And that's something that relatively few people have talked about publicly, and something that actually makes a lot of sense when you start looking into the design of what can happen in that layer 2 plus layer 1 sort of setup. And to put things into perspective, maybe on the wider scale, you have like some chains, very few now, that are banking on just one chain to roll them all. And that's something like Solana and Aptos and Sui, who are doing great work just on the monolithic blockchain kind of framework. And then you have like a lot of others, pretty much everyone else, doing some kind of modular approach to blockchains with Ethereum and Tezos and a bunch of others leading the way, whether it's purely from a rollup perspective or from the app chain thesis kind of perspective with Cosmos and Polkadot and so on. So moving on to the next topic. What are the Tezos core teams doing in the layer 2 space at this point?
So the approach that the core teams working on Tezos protocol have taken for layer 2 is an approach called we call enshrined layer 2. In the Ethereum ecosystem, a few layer 2s like Arbitrum, Optimism have launched, but the property that they have is that in general, they are the product of a company. It's maybe a decentralized product, but it's launched by a company who has they're going to have their own token, they're going to have their own interest in like a specific roadmap, a specific agenda, and it can create friction because there's not an alignment necessarily between the interest of the Ethereum community as a whole and the interest of this rollup. So with the enshrined rollup approach on Tezos, the rollup engine is actually at the protocol level. So it's the entire Tezos community which as a community decides to say, we're going to create this rollup. We see it's not as a product, but as an extension of the main protocol. And that, in turn, carries a lot of benefits in terms of security, because it means that if there are bugs in a rollup, the main chain can have solidarity with the rollup and protect the rollup. So we don't see a situation where the rollup fails and the main chain continues. And I think that gives you very important guarantees if you want to use a rollup. The other aspect as well is the seamless use, the same gas token between different rollups, the same interfaces, one standard. So it's really treated as an extension of the L1 rather than a different system that comes and grafts itself onto it.
Yeah, so that brushes up on the next question I had, which is if you can talk about the benefits of enshrining that layer 2 into Tezos, the layer 1.
Yeah. So like I was saying, the benefit comes from the guarantees that are given to application which create on those which deploy contracts on those enshrined rollups. Essentially, you're saying this is not just someone's product. Essentially, the chain has solidarity with the entire with the entire product. So you get the same guarantees in some sense as if you were building on a main chain. If there's a catastrophic bug, and hopefully that never happens because you have good development practices, but L1s can fork, and that's a very, very powerful aspect. The fact that the L1s can fork means that most of the hacks that you've seen in crypto have been hacks of applications and exchanges, but not layer ones. Layer ones have extremely rarely been hacked, and the reason for it is because they can actually fork out of out of bugs. But tomorrow, if Arbitrum has a bug in its code base, they cannot fork Ethereum. They cannot go to the Ethereum community and say, "Oh, wow, Ethereum should fork to protect us." And in fact, because of that, they are forced to be very centralized. They are forced to have admin keys that can control the entire rollup just so that they can go and fix bugs. So that's one of the benefits of enshrinement is the security, but the other one as well is the developer experience, having one ecosystem that's integrated, knowing that if a better rollup technology comes along, that rollup is going to be upgraded, and that's by deploying in this system, essentially you are benefiting from all the future upgrades which are coming on the platform.
Yep. Makes sense. And for the benefit of the audience, just to be super clear, what an enshrined rollup is, essentially that word enshrine means that the rollup code itself lives in the layer one blockchain's code. So that same code base has everything. Arbitrum 1 and the other rollups on Ethereum are smart contracts deployed at the app layer on top of that code base of Ethereum. So that's the main difference. And for extra clarity, Ethereum is also planning later on to have enshrined rollups when they identify the right ZK VM setup for it, etc. How does the overall approach, I guess we've kind of answered that one. Why is it better from an ecosystem standpoint that the activity takes place on layer 2 as opposed to layer 1?
Why is it better for the ecosystem as a whole, you say?
Yeah.
I don't think it's, so I would dispute that. I don't think it would necessarily like benefit the ecosystem as a whole. You can choose, if for some people, if you want to choose L1, because of the benefits it offers, L1 maybe is the right choice for you. For a lot of those applications, L2 maybe is the right choice. I think it's really about fitting the use case with the actual technology. Now, one of the benefits we have in people making the same choice is composability, right? If you want to have contracts talk to each other, it's a lot easier if they're all on L1 or all on L2. And this is also one of the reasons why the vertical scaling, just having like one big rollup where you have most of your activity as opposed to many smaller rollups, mean that you can have this composability that happens. You can have this contracts calling themselves atomically, creating those money bricks or money Legos that people talk about. That's what you get out of it. You can have communications between rollups and the main chain. So layer 1 and layer 2 can talk to each other. In fact, one way of defining those is that they are the first side chain in some sense with a secure bridge. Like the rollup gives you the security of the bridge between the two chains. But in terms of convenience, it's obviously better if people are using the same layer at the same time.
That's a great summary of this. Essentially, you have like some kind of two extreme use cases when it comes to blockchain users. On the one hand, you have users which are like mainly what we're seeing at the moment and what we've seen for a long time since DeFi summer. And those guys really don't really care at this point about the layer 1 for all intents and purposes on Ethereum currently, and BNB chain is doing some work there, and we are as well. What they care about is that soft confirmation that is given to them by the operator of the layer 2. So you go on Arbitrum 1, you have the sequencer telling you, okay, I have processed your transaction, and you have this implicit trust in the sequencer that it will not misbehave, do the right thing, and post your transaction to the layer 1. That's for most users, including me on my personal day-to-day things and stuff, that's what they care about. And that's for users who are doing things in, I don't know, like up to a single digit $1 million type of use case. if you're the BIS, SWIFT, or like a very large bank doing settlement at the end of the day, what you care about is the security of the layer one itself, with that best-in-class security and decentralization that Tezos, Ethereum, and others can afford you. And then in that case, you're not really in your place on the layer two, because at the end of the day, you would wait anyways for that full transaction journey to finish, and for the end of the what's called the challenge window in optimistic rollups to happen, which is equivalent to the security of the layer one.
I think it's fair to say that there's different benefits for layer two. Latency is one. Latency, convenience, user development, and cost. So it's a variety of things, and it's not. I would say it's a single one that that defines it.
Okay, and going into that topic a little more in depth, and maybe without going into full details, there's a lot of talk around the market around data availability. Mm-hmm. So last week, actually this week, we had the airdrop of Celestia, which is a data availability solution running on the Cosmos ecosystem as an app chain. And does Tezos have something that addresses that market? And how does it help performance?
Yeah, so in the works on Tezos has been a data availability layer, we call it DAO, and it's been running on Tezos testnets, but hasn't launched on the Tezos mainnet yet, but will be proposed to the governance process and maybe a part of a future Tezos. The data availability layers that we built for Tezos is based on the sharding of the data. So you take your data, you cut it in small pieces, and then you give it to the different validators of your system to keep. Now, what this affords you is that instead of having to download every single transaction and every single block, now a validator only has to download a portion that is proportional to their size. So if I'm a huge validator and I have a lot of stake, I'm going to need more bandwidth. I'm going to need more equipment. If I am a small validator, I don't need as much. So that really lets you increase the throughput of your chain. I've mentioned that layer 2 solutions can outsource the execution, so that lets you use faster machines. Well, what the data availability layer gives you is it spreads the cost of bandwidth across your entire network. And that's the other shoe, I would say, for scaling, is this data availability component. And so that's being built on Tezos, and it can be used in two different ways. One is a use case similar to Celestia, which is for external projects who want a cheap and reliable data availability layer, so they can plug themselves onto the data availability layer. But the number one reason it exists is to be part of this integrated experience where, by building on Tezos, you know that you can benefit from secure, high throughput, convenient rollups backed by a data availability layer. Donc it's about providing everything that the developer needs when they are building their application.
Makes sense. And to be clear, on the layer 2 solutions that we're currently helping to build, which is called Etherlink and is coming out in March 2024 for mainnet, there will be at the beginning just a reliance on pure data availability from the layer 1 without any data availability layer perspective. And later on, within months, we will be able to leverage that data availability layer that is being built on Tezos. So at the very beginning, we'll be doing the same as what other ecosystems are doing for data availability, posting a losslessly compressed batch of transactions to the L1 regularly. And later on, as DAL technology evolves, we'll be bringing that into the setup of our own offering within the Tezos ecosystem for that layer 2 called the Etherlink. One thing that I marked as optional in my notes, but what are some of the institutional use cases that can best leverage those layer 2 chains in the ecosystem that we're building and more generally as well?
Yeah, I think it goes to rethink about some of the use cases, because a lot of the use cases we've seen in the blockchain space have been largely determined by the lack of scaling. You know, if you can only handle 100,000 users at one time, it really limits the type of application that you can have. And you know, they exist, but it's typically we've seen a lot of trading applications because the value per user is extremely high, but only a certain type of trading application. Once you start having all the throughput that you want, the one thing is that you can use this throughput for computation. So now that you have all this, you can process more compute. It doesn't have to necessarily be more transactions, but it could be transactions that require more computation. For example, we've seen a lot of decentralized exchanges use techniques like curves and Uniswap in order to do trading, but the dominant form of trading venue is the double auction continuous double auction order book. And that hasn't really happened on blockchains before because of the cost of computation. Now that Layer 2 dramatically dropped down the cost of computation, you can have these different markets. So you can have order book type of markets. You can have much more complex financial primitives being built. So that's one aspect. And the other aspect is just the number of transactions, so having more people. So more complex transactions, more complex financial use cases, and use cases targeting potentially millions or hundreds of millions of people at the same time, as opposed to niche audiences.
Yeah, I think that's a good point to sort of conclude that part of the talk. And maybe we can conclude with one more question, which opens up the debate. What is the future focus of Tezos, and what is the roadmap?
Okay, so Tezos itself is a blockchain, so it cannot have a focus, but the teams building around Tezos, so Nomadic Labs in Paris, Trilitech, and a few others, who are working on making protocol proposals. And the direction is, I would say, threefold. Developer experience. So we've seen a lot of blockchains in the past launch with custom programming languages, a lot of experimentation and ideas, and Tezos is, of course, no exception. But I would say the market has really demonstrated an interest in mainstream programming languages. And so being able to support JavaScript, .NET, or Python code bases to develop smart contracts as opposed to these very, very custom programming languages is one of the main aspects. Having this interoperability between languages, so including things like Solidity, of course, for legacy purposes, but these mainstream languages. That's one aspect. The other aspect is throughput. We've already demonstrated 1 million transactions per second, but the goal is to do that within a single rollup with vertical scaling. And the point of throughput is, well, credibly telling everyone that the transactions can be cheap and can stay cheap. And finally, latency, improving the latency, reducing it from seconds to hundreds of milliseconds. Once you have that, I would say you have probably one of the best blockchain environment for any type of application.
Great.
We have time for a question.
Tell us. Yep. So we're seeing something that in the UK and the EU is a bit different from what's happening in the US, or maybe it's just a bit ahead, and the US might catch up later on. We'll see. But in the EU, since the beginning of the year, you had two pieces of legislation which are quite major. One of them is called the EU DLT pilot regime. It's the lesser known of the two, and the other one is called MiCA. And MiCA has been quite publicized, and Coin Bureau talks about it all the time, and so on. The EU DLT pilot regime, really what it targets is incumbents, existing financial institutions, trying to experiment with the blockchain to lower their costs, gain efficiency, and so on. And that is starting to see some pickup in Germany, in France, in Lithuania, in a few places. From the financial services side at first, because that's what the regulator wants to target first. I'm so sorry. So that's been like the direction that things have been going. For a few months, it was a bit slow, and a lot of incumbents didn't really know how to leverage that framework. Now that it's been clarified a bit, and that so there is a very clear focus on settlements on-chain to make trading more efficient, and any sort of settlement between financial institutions easier at the end of the day, or this kind of thing. The other use case that MiCA in particular makes clearer is stablecoins. And so those stablecoins and the work on stablecoins, Societe Generale has been pushing one, and JP Morgan has been doing one for a long time, and so on. So those use cases are made easier, arguably, going forward by more regulatory clarity. And for example, the UK has more or less adopted that framework. With Brexit, they don't have to anymore, but they did, with a sandbox that is very similar to what the EU DLT pilot regime does for you in the EU. So those are the kind of things that for now are happening. Hopefully later on with account abstraction, smart accounts, and a much more approachable onboarding experience for users, we're going to see an explosion of those use cases. But for now, those are the main ones being worked on. All right, I think we're kind of out of time. So thanks you guys for attending.